Welcome to video 2.3b, Expand Binomials with Pascal's Triangle. All right, so first we're going to do some investigation and then we'll apply it later on. So here's the investigation. Let's just expand the binomial a plus b to the 0, 1, 2, and 3 and see if we can find a pattern. So anything raised to the 0th power is 1, except 0 to the 0th, and we'll save that for calculus. So this is just a big 1. Okay, a plus b to the 1. Anything raised to the first is just itself. Now for the investigation, it's helpful if we list the coefficients, so I will insert 1s as needed. So I'm going to say 1a plus 1b. I'm making my 1s fancy just so they stick out better. A plus b squared, you could FOIL it, you might have it memorized. 1a squared plus 2ab plus 1b squared. Again, if I were to FOIL it, a plus b, I'd get an ab term there and an ab term there, and 1ab plus 1ab, that's what gives me the 2ab. And hopefully you can see the a squared and the b squared. Okay, and then finally, a plus b cubed. Okay, well why don't I make that be a plus b times a plus b times a plus b. And a plus b times a plus b we just did there. So let me kind of remove that and go a squared plus 2ab plus b squared. All right, now I gotta do those magic arrows. So I'll just multiply everybody through by a. So that's going to be a cubed. Hopefully I won't run out of room. Plus 2a squared b. Plus ab squared. Okay, this is the one that gets confusing. Then I'll do the other arrows in green. All right, so instead of saying ba squared, I'm going to call that a squared b, and put it in that column there. So 1a squared b, b times 2ab, 2ab squared, I'll put it in that column right there. And then b times b squared is b cubed. I don't know if I'm going to squeeze this in here, but I'm going to add all these together. I'll write it next door here. So that's going to be a 1a cubed plus 3a squared b plus 3ab squared. 3ab squared, sorry about that. Plus 1b cubed. Whew. Okay, so that was just expanding to an exponent of 0, 1, 2, and 3. Now Pascal's triangle. So you are going to need to know Pascal's triangle. So it always starts with a 1 at the tippy top. And there's always 1s on the outside, kind of like an evergreen tree. The top row, we don't call row 1, we call row 0. Okay, so it goes 1 and then 1, 1. A common mistake, I see it every year as students put that in there. So 1, 1, 1. And then once you get that, it's easy to see what's going on. 1 plus 1 makes 2. Oh, 1 plus 2 makes 3. 2 plus 1 makes 3. 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 makes 4. Let's try the next row. Okay, so a 1 on the outside, summing 5, summing 10, summing 10, summing 5, and 1 on the outside. So that would be row 5. Hopefully these are showing. Row 5. Okay, now let's see if I can see a connection here. oh, I raise this to the 0th power. I've got a row 0. I've got a coefficient of 1. And I've got a 1. I raise this to the 1st power. I'm in row 1. I've got a 1 and a 1. I've got a 1 and a 1. I raise this to the 2nd power. I'm in row 2. I've got a 1, a 2, and a 1. I've got a 1, a 2, and a 1. I raise this to the 3rd power. I'm in row 3. I've got a 1, 3, 3, 1. I've got a 1, 3, 3, 1. Okay, so Pascal's triangle is giving you the coefficients of the expansion. So all you've got to worry about is the lettering scheme, and I'm going to show you that in the next example. But let's just take a quick look at a cubed, or a plus b cubed. So, oh, notice I start with the first letter to the highest power, and then it's going down 1. So a3, a2, a1, a gone. B not there, b1, b2, b3. So the first letter's exponents are going downwards, and the second one is going upwards. So we will use this connection to do some more examples with expansions right now.